This is Module 2, Lesson 13. How can we use alternate interior angles and corresponding angles to prove the interior angles of a triangle sum to 180 degrees? Turn to your binder for Lesson 13, and the first picture is 3 different triangles. An acute triangle, an obtuse triangle, and a right triangle. And in each of the triangles, if you add for triangle 1, if you add angles 1, 2, and 3, in the middle triangle, if you add angles 4, 5, and 6, and in the last triangle, if you add angles 7, 8, 9, each of them in each triangle add to 180 degrees. Also, because the last triangle is a right triangle and angle 8 is a 90-degree angle, 7 and 9 have to also add up to 90 degrees. So this lesson is all about proving that the sum of the angles in a triangle add to 180 degrees. And you know that as a fact, and we accept it, but this lesson is about explaining why 3 angles in a triangle add to 180 degrees. You're going to prove it. You're going to explain why it's true. You're going to use an informal argument to explain why it's true. And to do that, you need 3 pieces of information. You need to be reminded that a straight angle is 180 degrees in measure, that corresponding angles of parallel lines are equal in measure. We discussed that in Lesson 12. And that alternate interior angles of parallel lines are also equal in measure. Okay? So let's look at the exploratory challenge. So turn into your binder. Turn to the exploratory challenge number 1. And there's a diagram, and the directions say, let triangle ABC be given. On the ray from B to C, take a point D so that C is between B and D. So the picture has already done that for you. So if you notice, they've extended this ray, BC, and put point D there. And then they've also, through point C, they drew a line that was parallel to AB as shown. So this red line here is drawn, and this angle here, this line here, AB, let's see what happens if we extend them. And if you turn your book or your binder slightly, you should start to see that it looks like the red lines are like the 2 parallel lines, and line AC is the transversal. So we start out looking at the triangle ABC, but now all of a sudden we're looking and we're noticing that AB and CE are the 2 parallel lines cut by transversal AC. So in this problem, in this drawing, we're going to name the 3 interior angles of triangle ABC and name the straight angle, and then we're going to answer some other questions. So the 3 interior angles you should see are well, there's one called ABC. So that's the first angle. Angle ABC. The second angle is angle BAC. Oops. BAC. So that's angle BAC. And the third angle is angle ACB. And the straight angle, you should notice, is angle BCD. The next question is, what kind of angles are angle ABC and angle CED, and what does this mean about their measure? So let's look carefully at those angles, ABC and ECD. I'm going to get rid of some of these color lines here because I think it gets distracting. So I'm going to erase some of these lines. Okay, so now we're back to the question, what kind of angle is angle ABC and EDC? Well, if we still want to talk about these lines being two lines cut by a transversal, then let's extend those lines again. And angle ABC is right here. And angle ECD is right here. So if you've got two lines cut by a transversal, those angles should look like corresponding angles. So we know then that those two angles are corresponding angles, so their measurement is equal. So we're going to add that now. So to answer that question again, we noticed that those angles are corresponding angles, and they're corresponding angles of parallel lines because AB and CE are parallel, so we know that they're equal in measure. And now let's look at angles BAC and ECA. BAC and ECA. So BAC, so let's mark that. BAC and ECA. And if you look at those angles, if you need to turn your binder sideways, that's fine. But they look like the alternate interior angles being cut by a transversal. So what kind of angles are those two? They are alternate interior angles of parallel lines, so they are equal in measure. And our last question is, we know that angle BCD equals angle BCA plus ECA plus angle ECD, which equals 180 degrees. So now we're going to use substitution to show that those three interior angles of the triangle have a sum of 180 degrees. So let's go back and look at those angles now. Let's get rid of some of the markings, and let's go back and mark those angles again. So we're talking about angle BCA right here. And then we're talking about angle ECA, ECA, which is right here. Here's the first one. There's ECA. And then angle ECD. Okay? We'll mark them again. Here's the first one, here's the second one, and that's the third one. So together they make up a straight angle, which is 180 degrees. So let's make some substitutions and see what we get. So using substitution, the straight angle, which is BCD, BCD is the straight angle here. There's three angles here that make it up. So angle BCA, this one right here, that's on the interior in the triangle, plus angle BAC. BAC. We already said that angle BAC was the same thing as ECA, which is this angle right here, ECA. So this angle right here can be substituted for this angle here because they're alternate interior angles, plus angle ECD. Well, we already said that that's corresponding angle to ABC, which is on the inside of the triangle. So if we know these three equal 180, this is inside the triangle, these two can be substituted with this angle here and this angle here. So we've just proved that the sum of the interior angles equals 180 degrees. Turn to the next problem in your binder, which is exploratory challenge number 2. And it gives you a figure with two parallel lines and then two other intersecting lines. There's line 1 and line 2, which are parallel, and M and N are transversals that intersect lines L1 at B and C. So here's the transversal M, here's B on line 1, and here's C on line 1 from the other transversal. And line 2 has point F here. And we have A on line 1 and to the left of B, and we have point D on line 1 to the right of C, and we have point G on line 2 to the left of this point here, and we have E on line 2 to the right of F. So let's name the triangle in the figure. So the triangle in the figure is triangle BCF, and name a straight angle that will be useful in proving that the sum of the interior angles of the triangle is 180 degrees. Well, look at the straight angle GFE. Let's look at that, GFE. GFE is a straight angle, but notice that it's separated into this angle, and this angle. Three angles, which we're then going to use to help us prove part C, which says to write your proof below. So we're going to prove that the three angles in this triangle sum to 180 degrees using this straight angle here. So this is how, why don't you turn off the video and you try it now. Go back to the first problem we just did and look at these two parallel lines. Notice there's a transversal here, so you may find corresponding or alternate interior angles looking at this transversal, or if you look at this transversal here, transversal N, you may find either alternate interior or corresponding angles. You want to find, if you're using transversal N, you want to find something that matches to this angle here, angle BCF. Something matches to this. And if you're using, you would use transversal M to find something that matches angle CBF, this angle right here. Okay? So you need to find a comparable angle to this angle, and you need to find a comparable angle for this angle right here. And in the last problem, it was helpful if we found a corresponding angle and an alternate interior angle. So turn off the video and try that now. Okay, so now let's see what you could have done. Check with what I have here. Please make sure you've tried this on your own first or gone back to the first example. Just copying what I have here is not really going to help you to understand it much unless you've tried it yourself. So here's our proof. The straight angle, angle GFE, is comprised of these three angles. So alternate interior angles of parallel lines are equal in measure. So for that reason, angle BCF and angle EFC and angle CBF and angle GFB. So let's look at those. So we've got BCF and we've got CFE. CFE. These two angles right here are alternate interior angles. Then we've got angle CBF in the triangle. And we've got these two angles here. So in both cases, we've been able to find an alternate interior angle. So this angle here is congruent to this angle here because alternate interior angles created when two lines of parallel are congruent. And the same thing over here. These two angles here are alternate interior angles if you use transversal M and lines L1 and L2. So in both cases, we've got alternate interior angles. And we know that all three of these have to add to 180. We know these three do add to 180. This one, this one, this one, and this one. So that's why in our proof, we can say angle BCF, and follow along with your finger. Follow BCF is equal to EFC because they're alternate interior angles, and angle CBF, the other angle in the triangle, is equal to angle GFB. Another alternate, they're both alternate interior angles of parallel lines, so they're congruent. And since GFE is a straight angle, it's equal to 180 degrees. So therefore, if you angle GFE is equal to angle GFB, use your finger to follow the letters, angle BFC, and angle EFC equals 180 degrees. And then you can substitute. For GFB, you can substitute CBF. And for EFC, you can substitute BCF. Therefore, the sum of the interior angles of a triangle is 180 degrees. Please look this over again because I think for some of you this might be a little confusing. I want to make sure that you took the notes when it was appropriate. Please read the lesson summary on page S70, which says all triangles have a sum of interior angles equal to 180 degrees, which you knew, but now you know that the proof that a triangle has a sum of interior angles equal to 180 degrees is dependent upon the knowledge of straight angles and angle relationships of parallel lines cut by a transversal. Please be prepared with questions on lesson 13. This concludes lesson 13, but I need you now to go ahead and to please try the problem set questions. This is the first time I'm asking you to do the problem set questions. The problem set questions are 1 through 9. There are a lot of them, so I'm going to add that here. please also complete the problem set questions 1 to 9 and the exit ticket 1 and 2. Okay? And we're going to go over all of that on when we meet again. This concludes lesson 13.